Okay, welcome everybody to the Back to Basics webinar. It's great to have so many people interested in MongoDB. Let me confirm, a few people have been asking in the chat room, this whole session is being recorded and will be distributed and posted on the web. It will be sent an email to everybody who's here today, but you'll also be able to pick it up on our blog and other mediums. So you will be able to keep your questions to the end, or certainly put them in the chat room, but we will cover the questions at the end. If there are too many questions, we can take a snap of the questions and we'll get back to each individual directly. So if your question isn't answered in the actual session, then don't worry, we will get back to you. And there is an email box, backtobasics@mongodb.com, which we'll share with you at the end. If you've got any additional questions afterwards, please send them to that email address. The session should take about an hour. That's about 30 to 35 minutes of me talking, and then we'll leave about 20 to 25 minutes for questions at the end. As I said, ping your questions in the chat room, and we will capture them and try and respond to as many as we can at the end of the talk. Otherwise, we will cover them off as we do via email. So this is the first part of a 6-part series, which will be running from now until the end of August. There's a bit of a gap at the end because there's holidays. Even I have to go on holidays once a year. So this is the first part, Introduction to NoSQL. And I'll go through the actual agenda of this day's work in the next slide. But we'll follow this with your first MongoDB application, which gives you essentially experience of building an application hands-on, basic interaction with the database, some understanding of how you build indexes and how you use MongoDB like you've used databases you know and love. Then we'll go on to a more detailed design session, thinking in documents about how you work with dynamic schema design, how you think about schema in the context of the MongoDB database. Then on the 5th of July, we'll talk about advanced indexing. It's not just plain and simple indexes in MongoDB. We also have full text indexes and geospatial indexes, and there's some subtleties to how those work. We'll then talk about the aggregation framework, which is essentially a framework for producing pipelines of operations to transform your data. Think of it like an analytics engine purpose-built for MongoDB. And then we'll finish up in August with production deployment, which talks about some of the issues you need to think about as your application starts to get deployed in production. And anybody who's read the news will know the first thing you need to know about production deployment is turn on your security, usernames and passwords, access all of that stuff, and make sure you turn it on. Do not put a MongoDB database on the public internet without security. Can I just confirm that the majority of you can hear me speaking? I know some people have said there's issues. Maybe people can drop me a line on the chat room if you can hear me loud and clear. If I see lots of loud and clears, I'll go right ahead. If I can't, then I'll stop. That looks pretty healthy to me. Thanks, folks. Okay, so the agenda for today. We're going to talk about why NoSQL. Why the big deal about NoSQL databases? Why should we care about NoSQL databases? Once we understand the reason NoSQL databases exist, we'll then talk about the different types of NoSQL database that you can see today. Just to give you an overview of what's out there in terms of the types and taxonomy. We're not going to go into each vendor or each open source project in detail, but at least by the end you should understand basically the difference between a graph database and a document database. We're then going to give you a little bit more detail on what MongoDB is. And MongoDB is a document database. So you understand what MongoDB does for you as a developer and a programmer. And then finally, we're going to talk about 2 fundamental aspects of MongoDB that you'll find in lots of other NoSQL databases, but we're going to talk specifically about how MongoDB addresses the concepts of data durability, as in how can we guarantee that we won't lose data once we put it in the database, and scalability. How do we handle web scale loads when we go from hundreds of users to hundreds of thousands of users to millions of users? Then at the end, we'll have a question and answer session. So the world loves relational databases. They've ruled the roost for over 40 years now. Ted Codd's seminal paper in IBM in the 1970s set the stage for the biggest transformation in how we manage data since the computer was invented. And why do we love them? Well, they have this amazing expressive query language, SQL, that everybody can learn. Even a moderately talented technical person like myself can get their head around SQL. And they have rich secondary indexes, so the table structure can still be queried really efficiently and effectively. Secondly, they've got strong consistency. They're easy to reason about. The changes that you make in the data in one part of the database are consistently seen by the rest of the users of the database. And that's the way we think about the world. I make a change over here, you see the same change over there. That makes for a very simple programming model, and again, it's one of the reasons why relational databases are very easy to use in very complex environments where the data sets are changing very rapidly. And finally, enterprise management and integrations. The ability, because this technology is deeply legacy and embedded in everything we do, it connects to everything. So when you drop a new relational database into your data center, you know it's going to connect to Tivoli or HP OpenView. You know your backup tools are going to work with it. You know it's going to be certified and verified on the storage systems that you're using. This makes it great for doing just about anything we do in a business today. And if you scratch the surface of any business, I guarantee you at the bottom is a whole pile of relational databases. But the world's changed. The challenges we face now are the explosion of data. 90% of the world's data was created in the last 2 years. And that data is predominantly unstructured data, which is not to say it's data that doesn't have a structure. It's just a structure that is really, really hard to represent in tabular or rectangular form. The data varies in size. It has hair on it effectively. So that explosion of data has presented a huge challenge for relational databases. And of course, as we move to data-driven businesses, the number of businesses today that completely depend on data to run their business, that want data access that's 24/7, 7 days a week, that want to have uptime all around the world. There's always a user that's awake using Google. There's always a user that wants to buy something off Amazon. So there's no more opportunity to turn these systems off at the weekend or late at night. They must remain up at all time. And therefore, as we scale out these systems, they must be resilient to failure. If we combine this explosion with data, with the massive demand for uptime, we also see we're under increasing time pressure. Projects must be delivered in months instead of years, in weeks instead of months. And of course, the price pressure to make sure that the value of the projects is maximized means that we want to do that at the lowest cost possible. So the challenge we face is that the massive infrastructure costs that we've borne in the past are no longer something that we're willing to put up with. So data and risk exploding, time and cost under tremendous pressure. This is the environment that 10 years ago that basically created a space for NoSQL databases to develop. And what do NoSQL databases give you in the large? The number one thing is effectively the ability to manage your data dynamically, the ability to store a range of different data sets in the database and change what you store over time. This flexible approach means that you can adopt those kind of agile development technologies that people know and love, where you can start a project and go into production without fully understanding how this project's going to end up once it gets into the hands of the customer. So the ability to change what you do on the fly based on changing customer demands, based on changing customer requirements, is one of the number one reasons why people adopt NoSQL in the first place. It's definitely one of the number one reasons why people pick up MongoDB or download it and start working with it. The idea that you don't have to set your schema design in stone. The idea that you don't have to turn off your database to change the table structures. The idea that your DBA isn't going to absolutely freak out because you have to run an alter table on a 1 billion row database. Secondly, scalability and performance. As we move to web scale, as we move to mobile devices with 12 sensors each sending data every couple of hundred milliseconds, as we move to high-resolution cameras, as we move to instant on and instant response time globally, we need a database that can handle that. And single node databases are challenged in two ways. One, the latency of getting the data from where it is in Japan to where your database is located in New York is really substantial in those kinds of time frames. And secondly, to put all your eggs in one basket and watch that basket is great as long as that basket is fine. But if that basket fails in any ways, your challenge to respond and restore service is enormous. To get the scalability and performance that we need for modern web applications, we need a distributed database which is insulated from any single point of failure. So the ability to grow with the load on your system by essentially adding low-cost commodity or cloud hardware is a key enabler of NoSQL. And of course, the people who kicked this all off, Google, have a massive cluster of nodes. Amazon offers the same thing. And so what you'll see at the bottom of most NoSQL databases is essentially a cluster of modestly powered servers that can scale linearly based on the load and demand of the system. And scalability and performance isn't just about being able to handle a load, it's being able to offer a consistent response time as that load grows. It's absolutely no point if your customers in Japan are experiencing 600 millisecond delays while your customers in Dublin, where I'm based, are getting 150 millisecond delays. And of course, that challenge of global deployment demands an always-on infrastructure. You can't turn your systems off. So the ability to build on a distributed hardware base which can survive single points of failure like individual nodes or power supplies or even segments of the network failing is a key enabler for NoSQL. And it comes from that idea of building on a distributed technology base. The assumption is we're going to build a large, low-cost, simplified cluster that can handle itself when things fail. On the other hand, most of these databases in the NoSQL marketplace have made some sacrifices in order to make these changes available. They often are just key value stores which don't have an expressive query language or don't support secondary indexes. Or they use eventual consistency so that the writes that you see happening in millisecond 1 are not available to clients around the world until seconds later. Or they're young enough and they don't have the integration into the stacks we know and love. So one of the classic challenges as we move into the early majority of technology adopters is it's got to work with the stuff that they know. So if you don't integrate with Tivoli, if you can't use the monitoring tools that they have, if you can't work with the backup systems they have, then there's a huge barrier to entry for these modern technologies. So MongoDB is actually here to address those whole concerns. It's what I like to describe as the most relational, non-relational database. So we have an expressive query language and we allow you to set up as many secondary indexes as you need to get the query optimization that you want. We have a strongly consistent design. So what you write to the database is consistently seen by all other readers, including the reader that wrote the data. We have designed this database for over 7 years, and we've built a large stack of integration software that's designed to work with the techniques and technologies that you know and love in your existing data center. So our Ops Manager and Cloud Manager tools are designed to integrate with existing infrastructure. And of course, we bring you the flexibility, scalability, and performance that you've always wanted from a NoSQL database. And it's what we call our Nexus Architecture. It's designed to give you the best of both worlds. All the stuff you know and love in relational combined with all the stuff you know and love in NoSQL databases. So, what do we mean by NoSQL databases? Well, there's basically roughly, and people will slice and dice on this quite a bit, 5 main types of databases you're going to see in the NoSQL world. And I'm going to go through each of these in turn, but effectively they are key value stores, column stores, graph stores, multi-model databases, and document stores. MongoDB is a document database, and I'll talk in detail about what we mean by a document database at the end of the talk. So what's a key value store? It's effectively an associative array. It's a single key lookup. It's like a hash or a dictionary, depending on your favorite programming language. And the main way it changes is that it distributes this hash table or associated array over multiple machines. So the most popular originator of this idea was memcached, which was designed to sort of optimize live journal way back in the day. But memcached was just purely an in-memory hash. So what we've seen is lots of people take that hashing approach and turn it into essentially a durable storage environment so that the writes you make to those caches are stored on disk. And for single key lookup, it's super fast. Associative lookups are absolutely blazingly fast. So if you're using key value store for an e-commerce basket, it's fantastic. I can go straight to Joe Drumgoole, get his e-commerce basket, see what products he's got in it, and very quickly display that on a screen. And so we love that. However, it's not so hot for what I call reverse lookups, where you're looking into the value for data. So if I ask a key value store, give me the total number of shopping baskets over $100 that are located within the Greater London area, well, you effectively have to do a table scan because you have to retrieve every key and look into the value and look at the data in order to analyze that data. So key value stores, great for single key lookups, not so hot when you're trying to look at additional analytic data or do the kinds of traditional queries we know and love in relational databases. Then we got column stores. Now, before I get into column stores, I just want to do a quick reminder of the way that row stores or traditional relational databases like MySQL store their data. So effectively, we store the data on disk. We materialize the row structure of the tables on disk directly. So it's stored row after row. And of course, these rows are essentially statically allocated and of fixed size in a relational database. So it's very easy to scan up and down by using basic multiplication to do seeks to the different locations. The row stores are great when you want to pull out row data, right? When you want to look at a specific row, and particularly when you want to look at a small subset of rows in a large table. They can do that very efficiently. On the other hand, a column store essentially pivots this on its head, almost like a pivot table. A column store stores the data in a table in column order, right? So essentially, when you store the data, you store all of the ID column, then all of the name column, then all of the salary column, then all of the start date column. So the columns are materialized on disk close together. So why is this a big deal? Well, for a start, you can grab a column much more efficiently than if you're trying to retrieve it from a row store. If you want to get a single column from a relational database which has 20 columns, you've got to pull all those columns off disk to get the single column you want. So when you do select star from, you're pulling the whole row because the coin of the realm in a row store is the row itself. So you can't pull subcomponents of a row. So if you just want to add up all the salaries for a set of employees in a large employee database, or you just want to see all the basket values for an e-commerce basket which can have a random number of products, this is much more efficiently done in a column store where you can just pull that column data directly. And of course, because the data types are aligned and of the same type, you can compress that data super efficiently. So when you're reading it off disk, you can read disk blocks that are typically compressed by up to 30 times smaller than they are in memory. So that means you can get more data in a single seek. Now you still get row-level attributes and row-level operations, so you can align your rows by effectively inserting a row ID, or by aligning the rows by essentially knowing the order of the different columns on disk. So if you need just a small number of columns, you don't need to read all the rows. So when you're doing columnar access or analytics, it's super duper efficient, right? But updating and deleting by row, by the contrary way, is much more expensive because you've got to go down the columns and find the row elements, right? They're much more effective for append only, and of course, we use them for online analytics processing. If you scratch the surface of Vertica or HANA, what you'll find is a column store for doing analytics, right? Then for online transaction processing, for updating and managing something like a shopping basket, then that would definitely be something you want to look at a row store for, or better still, a NoSQL database. So the common column stores that you'll know and love are Vertica or Cassandra, and there are a few others. HANA has a column store component to it. So if you're doing those analytics, that's the kind of thing that people tend to use. Graph stores are really what they say on the tin. If you want to store a network of connections where the network is growing and shrinking, a social network, the network of parts in a bill of materials, the network of relationships in a group, it's great for that, right? It's designed to allow efficient traversal, essentially by hard coding the network links into the records in the graph store. They're often built on a key value store with the ability to store links as an extended type. And if your use case is not a graph, you don't need a graph database, right? So, I mean, don't be picking up a graph database if you're going to store the inventory of a large, component system. Don't be using a graph store if you're going to be storing, salaries. Graph stores have a very narrow use case. For that, they're great, but they lack some of the general purpose database capabilities that we know and love. And then we've got the sort of new kid on the block, multi-model databases. These guys are designed to combine multiple storage and access models. So for instance, you can store a column store and a row store together, so get the best of both worlds. You double your storage costs on the disk, but surprise, surprise, storage costs are for nothing these days. It's often used with a graph plus something else because we know the utility of graph databases, but trying to do other things in graph databases, like essentially tabular access, can be painful. And it fixes the polyglot persistence issue. People have tried to do this up to now by essentially duplicating writes to different databases, but it's very hard to keep those two databases consistent and to get a consistent view of your data. So it's the new thing. We're going to see more about multi-model databases in the future. It's still pretty early days, so watch this space, I guess. So document stores, this is what MongoDB is. So when we say documents, we don't mean PDFs or Microsoft Word or HTML. What we mean is documents are nested structures created using JavaScript object notation. So this is essentially the contents of the JavaScript object is stored as a nested document, as you can see on screen. So it gives you the ability to store hierarchy. It gives you the ability to store typed information. It gives you the ability to understand the relationships in your code directly in the database. So strings, nested documents, arrays, integers, and geospatial coordinates can all be stored in document databases. And in MongoDB, we understand these documents. They're not just anonymous objects. Our point is we can understand and index these substructures. We can store JSON, but as a binary format called BSON, which is short for binary JSON, which makes it super efficient to encode and decode for things like network transmission and, of course, on-disk storage. And we can create indexes on any document or sub-document in this field. So we can reach into the internal structures of the document to do really efficient queries. We're going to cover all of these details later on in the course, but I wanted you to understand one of the reasons that makes MongoDB so powerful is the ability to manipulate JSON documents as powerfully and natively as we used to manipulate rows in a relational database. And why documents? Well, we allow dynamic structures. Each document can be different from the next. All it needs is some commonality if you want to index the whole document structure in the complete collection. We don't need an object relational mapping layer because, of course, we can store the documents that we keep in our code and that we use in our front-end systems directly in the database. And, of course, we get implicit denormalization because instead of exploding the object into loads of its subcomponents for relational storage purposes, we keep all the related components together. So we get implicit denormalization. So, in effect, we can eliminate all of the object relational mapping and encodings and just use the code, the application, and the database synchronously together without doing a load of mapping. And it's full-featured. We can do rich queries, geospatial queries. We've got full-text search. We've got an aggregation framework, which gives you the group-by capability that people love in Relational. And we've got full-blown MapReduce, so you can do deep introspection into your complete data set. And so we have a code at the top, an application with a driver, and that driver offers you access to all of these capabilities on the server. So that's the database in the whole. Now I'm going to talk to you a little bit about how we do data durability and performance in MongoDB. So we know that we can build distributed databases, but how do we ensure that the data is stored consistently and can recover from failures? As you move to large clusters of 50 to 100 nodes, there's always going to be one node that's down. So we can effectively define a replica set as a set of nodes managed by MongoDB, and when we create that set of nodes, we tell it how many nodes are going to be the member, and it creates a replica set with a primary. So effectively, when you tell these 3 nodes they're going to become a replica set, they have an election, and that election tells them which one of these nodes is going to become a primary. If it's a brand new database and there's no data, it's effectively random. If it's a real database, then what will happen is the one with the most current data will become the primary. And so now all connections and writes that come to the replica set are operated through the primary, and those writes are duplicated automatically to the secondaries. And you can have up to 50 secondary databases. So the primary gives you a consistent view of your data, and the secondaries guarantee that you've got data durability. And you can control the security of your writes by demanding that a certain number of secondaries receive the write before the write from the client gets acknowledged by the primary. So imagine we have a primary failure. Then somebody pulls the power cable, or the disk fails, or the power supply burns out. Well, straight away the secondaries will discover, because they're heart beating between themselves and the primary all the time, that there is no primary there, and they'll detect this based on some timing. Now, what these 2 secondaries do is they will have what's called an election. So they essentially agree with each other who has the most up-to-date data based on timestamps and the amount of data that they've collected from the primary. Once they agree which one has got the most up-to-date data, that becomes the new primary. And now the operation of the cluster carries on as before. Yes, we're a slightly less resilient cluster because we've got 2 nodes, but the time between the primary failure and the new primary coming up is of the order of seconds, and sometimes less than seconds, depending on how you configure your cluster. So now you've recovered your replica set, but what about the node that died? Well, we can go into our data center, discover that the power supply was burnt out, replace it, bring the system back up, and it will rejoin the replica set automatically. And it does what's called a resync. It essentially catches up to where it was before the primary originally failed. Once it's caught up, the cluster is now healthy and stable, and now we have a new cluster. Note the primary doesn't move back to the secondary unless you actually explicitly set that up with a priority mechanism that I'll show you later on in the course. So the primary will remain where it was allocated until the next failure or until the next issue. And of course, if you have 50 nodes in your cluster, you can survive more than 1 node failing. If you've only got 3, then more than 1 node failing will give you a read-only cluster because you don't have enough nodes to essentially have a successful election. But of course, that primary has a bottleneck. The bottleneck is that, of course, all writes must go to the primary and all reads must originate from the primary to give you that consistency that you want. You can read from a secondary node in a replica set, but you'll get asynchronous reads because the reads must, of course, percolate from the primary into the secondary node. So in order to scale out this system, we must give ourselves the opportunity to use multiple primaries to accept writes. And this is what sharding is. Essentially, we partition the data in our database across a shard key that we define. It could be username, it could be date of birth, it could be some internal ID, it can be a combination of fields. So your shard key can be as complicated as a query, effectively, so you can use multiple fields to detect and to analyze and split the code up. So now, what we do is we partition over a shard, and now we can add as many shards as we need to get the scalability that we want. And each shard will have its own primary. So you can see this is 3-node replica sets. You could have 4, 5, 6 nodes in each replica set. And now what we do is we partition the load over these shards. Right? So the shard key partitions the content. The MongoDB system will automatically balance the cluster. And of course, shards can be added dynamically to a live system. And the rebalancing of new shards happens in the background. The key thing is the shard key is immutable, right? So you can't change the shard key once you've defined it. So you need to be fairly careful about picking that shard key. And once you've got the shard key working, it will vector queries to a specific shard when it's used in a query. Where there are queries without shards, the query will be sent to all shard members. So, if you think of it like this, we have a separate set of servers that we deploy in a shard environment called MongoS's, Mongo Shard Routers. They take the requests from the client, and they will work out, using a set of servers that are added to the system, which shard to route queries to, or in the case where they can't work out which shard, they will send the request to all shards and gather the results. The MongoS's are essentially dataless, and then they use the shard key, the orange bar, to determine which shards to allocate queries to. And if I add a new shard, effectively the system will rebalance the data between the 3 shards that existed before now and the 4th shard that gets added. So what we've got is at the bottom replica sets giving you data durability and the ability to survive any single point of failure. And of course, in a sharded cluster, you could have one failure on each replica set and the system would continue to perform. Then we have sharding to give you the ability to scale performance by linearly growing the number of nodes that can serve the queries that are coming to your database. And then we have a large number of MongoS's, as many as you need to deploy, usually 1 per app server, that will essentially give you the ability to grab your data. So with a sharded cluster, we use a routing layer to guide queries. The daemon is called MongoS, and it's stateless. And you can run as many as you want, but typically you run 1 per app server. So, this is the end of the spoken part. We're going to move on to questions. I just wanted to remind you what we've covered today. Why NoSQL exists? Because of the explosion in data, the complexity and the unstructured nature of that data, and the challenges we face with traditional relational technologies in addressing the velocity, variety of that data. The types of NoSQL database, key value store, column store, graph database, multi-model, and document. MongoDB is a document database. And then we've gone through the key features of MongoDB at a very high level. We'll obviously get into a lot more detail in that, but I wanted you to understand that 2 of the key areas that all NoSQL databases strive to address, data durability and scalability, and how we've addressed those in MongoDB. A little bit of housekeeping now before we get to the Q&A. The next webinar, we'll talk about building your first MongoDB application. We'll actually show you some code. I may even write some code on screen. Definitely make sure to register for the second one if you haven't already. It will look at how to build your application, how to create databases and collections, which are essentially the analogous to tables or databases and tables in Relational. We'll look at how you do queries and build indexes, and we'll start to show you how to understand how you can measure the performance of a MongoDB database. There's a URL there which you can type in and register. All feedback about this series can be sent to backtobasics@mongodb.com. Myself and the other participants on this side of the fence will keep a look at that stuff. And with that, I'm going to look at some questions. Okay. So Pankaj Kumar asks, why we choose MongoDB when we have other databases in the market? I hope we've covered some of that rationale there. 1 is ease of use. 2 is the ability to manage dynamic schema. 3 is the ability to scale your database. And 4 is that it works more naturally with the programming languages that we use today. Srinisa asks, when we have Hadoop with SQL capabilities like Hive, which is distributed system, what is the need for NoSQL distributed databases? the bottom of a Hadoop layer is designed as a key value store to give you the ability to do very fast computation. On the other hand, it does not have the querying capabilities at the performance level that you would want to do what we call real-time querying with data that's changing. So for instance, if you're trying to track the state of a manufacturing plant where sensor data is coming in every couple of hundred milliseconds, Hadoop clusters can't do that. Hadoop clusters are great at querying static data sets that are changing very slowly, but it can't handle real time. Raunak Kumar says, no SQL DBs are said to be non-transactional. What do we mean by it? Normally we mean by non-transactional in the NoSQL sense that a transaction is essentially considered in the relational world to be multiple updates to different tables happening as if they're seen by one. When you have a table that's distributed across hundreds of nodes, creating locks across those tables essentially makes the system grind to a halt. So we're transactional around the updates to a document. Every single document in the MongoDB database, pretty much like the rows in a relational table, are transactional for updates. But for multi-document transactions, you have to do some work yourself in the application layer. Srinivas says, can you tell us examples of each type of NoSQL DB? Well, key value store would be Redis, column store would be Cassandra, multi-model would probably be OrientDB, which is both graph and relational. Raghav Shah, I don't understand if we select two column in MySQL. Okay, hang on, he's carrying on. Select FC1, FC2 from table, then there is slow. I don't know if that will be slower or faster, Raghav. It depends on how your tables are laid out, how they're structured. But yes, typically joins across collections, which are essentially our tables, will tend to be slower than pulling data from a single table. It's just the fact that you typically have to do two seeks or arrange for that data to be in memory, and you still have to join the data together. Kindly name a few NoSQL databases that fall under different. I think I've covered that already. Can you please give me an example for a line row? Manish, I'd need the context for that question. Maybe if you can send an email to Back to Basics and just give me a bit more background on what part of the talk you were referring to when you asked that question. Venkata asks, is RelTO a multi-model database? I've never heard of RelTO before. One of the challenges we face is there's 150 NoSQL vendors out there. Even the most smart, most dedicated individual is not going to know all of them. Maybe if you send me a web page, Venkata, I can have a look at that and let you know what my view of it is. Dotan asks, what is the disadvantage of MongoDB if we're comparing this to SQL? Well, we don't have transactions, so if you want to do multi-document transactions or multi-table transactions, you can't do that. If you've got an existing tool chain that's absolutely wedded to some part of your database, like for instance triggers that we don't support, you're going to have a challenge there. And of course, if your existing team is really, wedded to the idea of SQL, it can sometimes be difficult to make them change. So I think that covers most of that. Can I start without a shard and once I have some data add the shard in? Yes, you can, Bhupendra. Sharding is something that you can add at any time in the future. So typically we recommend people start with you typically start developing on a single node, then you move to a replica set, then you move to sharding as your performance starts to struggle with a single node primary. However, lots of our customers get a lot of work done using essentially a replica set with a single primary. So I wouldn't jump straight into sharding. Much better to understand your query patterns. Then you can effectively decide what your shard key is by understanding the ways it's used. Can each shard have its own replica set? Yes, in fact, Venkata, each shard has to have his own replica set. That's the fundamental design. So replica sets at the bottom give us data durability, and then a shard comprises of a replica set that's aligned by a shard key, which is managed by a set of what we call config servers that understand essentially, it's like an address book for the shard cluster. Zaymak Arano, can you please what a shard is again? A shard is essentially a partition of the database. Think of, in relational terms, it's partitioning your data, but you've got a partition on a key. Once you partition on that key and you tell MongoDB that you're using a sharded cluster with a set of replica sets, MongoDB will handle ensuring that that data is put in the right partition and can be addressed effectively when you do queries on it. Does data replication affect performance, asks Arjit Pal. Yes, it does. Because, of course, if you want to essentially do durable writes, which are guaranteed to be replicated on a quorum of nodes, then, of course, you have to wait for those nodes to receive those writes. So if I'm writing to a single node MongoDB, that write will return the minute the packet arrives at the server. If, on the other hand, I want to replicate to 4 or 5 other servers, then you have to do the round trip on the network, get to those servers, get the responses back, and then return to the client. So yes, there is a cost to data replication. No free lunch. Did you mention we can't read from secondary servers? No, Vignesh, we can read from secondary servers. However, that's at the cost of eventual consistency because, of course, writes to the primary have to be populated back to the secondary. So a write to the primary may take whatever the network delay is between the primary and the secondary and the time it takes to essentially persist that data on the secondary to appear on the secondary. However, there are a set of use cases where I don't need the most up-to-date data. So for instance, if I'm doing analytics on my open baskets, missing the last 50 baskets and a pool of baskets that runs to 100 million isn't a big deal. And in that scenario, reading from the secondaries makes perfect sense. A MongoS says, and MongoS, Zaymak, MongoS is the routing daemon you must run when you're sharding because it effectively sits between the client and the sharded cluster and knows how to route your queries and how to aggregate results. Colin Clark, what concurrency does Mongo have? It has lots of concurrency. So we adopted a new storage engine called Wired Tiger about a year and a half ago, and Wired Tiger is designed to be a lock-free storage engine. So traditionally, we've been challenged to get highly concurrent operation on very large boxes which have lots of CPUs. Wired Tiger addresses that problem and gives you the kinds of performance we expect from very large clusters or very large boxes with lots of CPUs and lots of memory. It's purpose-built for that. How does auto-increment work in NoSQL? We don't have auto-increment in NoSQL. You have to do this on a software level. When you insert a document into MongoDB, we give it a key automatically called an ID key, and that key is monotonically increasing, but you shouldn't depend on the difference between them because it's a combination of a timestamp, your Ethernet address, your process ID, and an incrementing counter value. So while no two keys on the same box will be smaller or larger than each other, you could get clashes between separate boxes or separate clusters. Suraya Arduhathi says, sharding is similar to partitioning. That is correct. So when a new shard is added, will data be redistributed? Yes, data will be redistributed when you add a new shard, and yes, there is a performance hit from the balancer to redistribute that data. So you can choose to run the balancer at a particular time when the load is lower, or you can manually split your data and repartition it yourself to ensure that you don't get that. Shanky Bansai says, where does replication sets keep their data? Same shard or different shard? A replication set is the repository for a shard. So effectively a shard contains an address range, and the blocks for that address range are stored in the replica set. Amitesh says, can we store unstructured data like images, video in MongoDB and build Solr indexes on top of it? You can store unstructured data. It's a component I didn't talk about today called GridFS. So GridFS gives you the ability to store any kind of binary data. So there's a limit within a document to 16 megabytes. GridFS gives you the ability to store any size of document, essentially by breaking the document up into chunks and putting it in the database. And then you can store the metadata with that for that image alongside it. And then you can build indexes on that metadata. So if you wanted to build Solr indexes on it, you need to take the data out and inject it into Solr. But you can capture and store the metadata you have for that image, or that you've extracted from that image or from that audio or from that file, in MongoDB and query the two directly. Venkata asks, as it is all writes to primary and reads go to secondary, how consistent are the reads? No, sorry, I didn't really mean that. All reads and writes should go to the primary if you want consistent writes and consistent reads. You can choose to read from a secondary, and then you will get eventual consistency, and the reads will not be consistent with the writes to the primary. Raj Seku says, do you have any IDE to interact with MongoDB? We've recently launched in MongoDB 3.2 a Compass tool, which gives you the ability to look at the data graphically in the database and build queries and get result sets. I recommend you download and have a look with Compass. It's a component you must pay for, but you can evaluate it for free by downloading it from our website. How do we execute queries apart from the command line? You can run a Mongo shell program that comes with the MongoDB server, and it's essentially a JavaScript interpreter, and you can write JavaScript code straight into that shell and query the data. You can also use the Compass tool I just talked about to essentially pull data out of the database and get a graphical view of it. Nitin Parab, is there any book I can start with? The MongoDB documentation is one of the best places to start to look at this stuff. Also, there's plenty of MongoDB presentations on SlideShare. The best book, but it's a little out of date, is MongoDB, the Definitive Guide, but it's only current up to 2.6, and we've done quite a bit in the database since 2.6. So I would start with MongoDB, the Definitive Guide, but make sure you cross-reference it with our online documentation. Raghavendra Reddy Red asks, what is a good example for column stores? I've already mentioned that. It's Cassandra. How easy is migration of existing DB from Sybase to MongoDB? We've had customers migrate relational databases in hours to days. Talend has some very good connector tools for doing automatic migration from MongoDB, from relational databases to MongoDB, and I would look at that. And Talend is an open source tool. Kankaya asks, is there transaction management? Only at the document layer can. We only allow you to essentially do transactional operations on a single document. Think of it like a row in a relational database. Subodh Paddy, what type of organization can use MongoDB? We're used by startups. We're used by very large companies. Bosch uses us for their Internet of Things framework. MetLife uses us for their wall application that does their essentially all their customer relationships. The Guardian uses us for content management. Sitecore, the world's largest content management system alongside Adobe Experience Manager, uses us for their Experience database. And of course, Adobe Experience Manager uses us for their content database. Semak Aronov, can you please explain the difference between the different NoSQL DBs? I think I covered that in the talk. If you're still confused, Semak, send me an email to Back to Basics and we'll get you an answer. How does MongoDB compare with other document stores? We were doing documents when it was neither popular nor profitable. So we've been doing this for 7 years. So all the other document stores have added JSON capabilities as a bag on the side of an original implementation of key value store. we fundamentally are documents through and through. The indexing system, the query engine, everything about MongoDB is built around the idea that we store and manipulate JSON documents. And we're the only people that have an open standard for defining how to map a JSON document into a typed object called BSON. And bsonspec.org is an open standard anyone can implement. Talatam, what is the disadvantage of MongoDB if we compare this to SQL? I think I covered most of that. Does it require some special hardware to install MongoDB? No, we run on just about everything. OS X, Linux, Windows, Solaris. The only system we don't run on at the moment, I think, is PowerPC. How many concurrent read-write can be performed on MongoDB? A lot, and it depends on the size of your cluster. I've got 10,000 writes a second going on my own laptop here by really saturating the disk with clients. But it absolutely depends on your system. I have SSDs on my Mac. Spinning disks will obviously impact your performance. Do not do the Vinayak. Do not do what most people do, which is they write a single loop, run it on the MongoDB, and say it's really slow. You need to put concurrent writers together and concurrent readers to really exercise the system. Can we port an existing relational database to NoSQL? Asks Sirdar. Yes, you can, and lots of people have. It's not an automatic process because typically you map a very large set of tables into a much smaller set of collections. But like I said, tools like Talend can definitely help there. Jeff Chan asked the same question. Is there any tools that help developers change their application encoding from traditional RDBMS to MongoDB? There are lots. JSON Studio and Talend both help with that kind of thing. What is the maximum size of document that can be stored, says Longanathan Thangaraj. 16 megabytes is the maximum document. After 16 megabytes, we recommend you go to GridFS and you can store larger blobs in there. How is it different from HDMS for storing unstructured data? HDFS is a key value store, so it's great as long as you only want a single key for your data. And HDFS is purpose-built for essentially serving large files into MongoDB. It's not a database, it's a file system. So if you want to store blobs of data and read and have them read into Hadoop, HDFS is great. If you want to do anything else with HDFS, it's not so good. What are the pros and cons of a document data like MongoDB compared to other NoSQL DB? Again, I think I covered that in the talk, and if I didn't, send me an email to Back to Basics. How do we make sure that the data inserted in all the child tables without any issues? You have to write code to ensure that if you are inserting into lots of child tables and you want them to be consistently viewed, that you manage that yourself. One of the challenges, Rajesh Khanna, is that for large-scale web applications with large numbers of users, hundreds of thousands of concurrent users, nobody uses transactions, even if they have a relational database. It's just not performant for that level of reads and writes. Muthu Kumaran asks, can an application be built to run completely dependent on MongoDB without any use of? Yes, absolutely, and we have a huge number of customers that are doing that. There is no dependency in MongoDB to have a relational database anywhere around. It's a completely self-contained NoSQL database. Suman Kunwar, can MongoDB search in million? What would be the case if I had 1 million data and I needed to have a search in RDBMS? Can I use a light query? Not quite sure what you're asking here. We can efficiently search billions of rows, never mind millions of rows. We have a customer, Carfax, in India that stores billions and billions of rows of data and searches them very efficiently. I think you might be asking, can I do text search on billions of rows of data? And yes, you can, using the text search capability. How does MongoDB determine sharding? I mean indexing replication. The shard key must be picked by you. The indexing is also something that you decide on, and obviously it's just like any other database. Your indexes are picked based on the query patterns you see or expect to see in your application. The replication is defined up front, but can be changed on the fly. So you might decide to have a replica set with 3 members and subsequently want to add a 4th member or a 5th member. Tyler Pongrantz, how do you go from a relational database mindset to a NoSQL mindset? That's easy. You attend the rest of this webinar series and we'll tell you exactly how to rewire your brain. Sorry, I just lost my... Does MongoDB is secure enough to support banking applications? We have a very large number of banking and finance customers using MongoDB today. I encourage you to visit our website and look at the customers, but people like MetLife, people like Barclays, all using our system for mission-critical applications. Goldman Sachs uses us for global distribution of trade data. I would say, I'm based in London quite a bit, every single financial institution is deploying MongoDB at some level in their organization today. What about security? We support Kerberos and LDAP for login and secure access to the database. We support encrypted storage engines so you can encrypt the data on disk. We have complete username and password access controls. And we offer a complete audit capability so you can tell what's changed and who's changed it. Do NoSQL databases support transaction management like RDBMS? No, they don't, and I think I've covered that already. Will MongoDB team develop any product for any another SQL database types? We moved to a storage engine model in 3.0, and that capability allows us to build lots of different storage engines. So there's absolutely no reason in the future where we wouldn't have a column store there or another type of storage engine, even a graph store. Right now we have no plans to do that. Can MongoDB be used as an OLTP for banking domain? Yes, it can, Venkata, and it is being used for that today. Can you provide more details on locking semantics for distributed transactions requiring consistency? There is some blog posts on this, Mark. If you drop an email to Back to Basics, I will send you the details on how we do that. Siva Kumar Karupanan, how the root away happens in the case of primary failures. It's an automatic process, Siva Kumar. It just happens automatically. The election process is automatic. The election of the primary and the primary coming back all happens automatically. Rustam Rawat, is there any GUI available like PHP admin? Yes, we have a complete management framework in the cloud called Cloud Manager that gives you access to all of the PHP admin type capabilities. That combined with Compass, our GUI tool for data browsing, will give you all of the capabilities you need. Can you tell me about reverse lookup in NoSQL, how it will affect NoSQL? It's basically the ability to look in, this is specifically for key value stores, the ability to look into the right-hand side of a value or a key value store and query it. In other NoSQL databases, particularly MongoDB, you can set your indexes to essentially look at any part of the value in the system and create an index, Bala. Prasanna, if all the nodes in the sync and if the primary nodes fail, why the remaining nodes to agree to become primary? Are they already in sync with any node can become primary? What I think you're asking here is how do we decide which node becomes primary? Well, we use the node that has the most up-to-date set of data. So, for instance, I might be in the middle of writing to 2 secondaries. I might have completed the writes to the first secondary, but not completed the writes to the second secondary. If the primary goes down at that point, then the secondary with the most up-to-date set of data becomes the primary. And there's a heuristic that we use. It's loosely based on the Raft protocol to essentially decide which node becomes primary. If data is stored in the form of a document, are there multiple files created every time a record is created? No. Each document is stored as essentially an extent inside a single database file. So you don't effectively see, you'll see one database file per database. Pankaj Kumar, how does election happen between secondary nodes? Once the secondaries detect that there's no primary, and they do that with the heartbeat that they send every couple of hundred milliseconds, they'll essentially generate an election at that point. They'll say there is no primary, let's have an election. Abe Sukla says, what happens when primary and secondary both go down due to some error? Then how can we recover? Well, you're insulating from a single point of failure in a 3-node replica set. If you want more redundancy, you can create more replicas, and those replicas can be isolated by data center, by region in Amazon, by rack, by disk. So you essentially choose the level of redundancy you want. Obviously, if you want to run lots of MongoDBs, there's a cost in managing them and, of course, keeping copies of the storage. But you can increase your redundancy based on what your requirements are. They say, what is the benefit of MongoDB versus Oracle? I hope we covered that already. If not, please send me an email to Back to Basics. Not only NoSQL, even RDBMS provides scalability and durability. What's unique here? Yes, RDBMS provides scalability and durability, not at global level. It's very hard to build a relational database in which you have copies of the data in 12 to 20 to 50 data centers. It's also very hard to provide a relational database in which queries and writes can be located geographically. And if you can get that, the complexity and the cost of solution often wildly outstrips the ability of an organization to pay for that. Remember, we're under time and cost pressure in every project. Can we use MongoDB for an OLAP or data warehouse system? Yes, and people have done this. The aggregation framework, which we're going to talk about in episode 5, gives you a hugely powerful capability for doing analytics on a data set. The data warehouse capabilities can be adopted because we have a general purpose database which gives you the capability to address a lot of the concerns of a data warehouse. Nick Lesh, I have seen many products having relational database used as non-relational or more like NoSQL. Given that I'm a NoSQL vendor, I'm going to say NoSQL is better. But then again, I would say that. How does MongoDB differ from HBase Cassandra? MongoDB is a general purpose database which is designed for general purpose use cases. HBase is purpose built for serving data into Hadoop, and Cassandra is purpose built to be a column store, which essentially means it's good for analytics, and it's designed to be able to handle writes in a network partition. How is a faster document database? Can you talk about the architecture? Well, we get fastness from one. We're pulling individual documents rather than doing joins to get lots of parts of documents in a relational database. We use a storage engine called WiredTiger, which is optimized to be lock-free. So pulling data and writing data to that is super fast. The people that built that built the original NoSQL engine for Oracle, and before that they built Berkeley DB. So these guys really know their database engine, and that database engine is one of the key reasons we can be highly performant now on systems with large numbers of CPUs. Then the engine itself is simpler because it doesn't have a transaction engine built into it. So because we don't have to manage transactions, we can get fast performance that way. Sov Paddy, what is the license cost for production environment in MongoDB 3.0 version? Give us a call, Sov. I can tell you it depends on your region and where you're based and what currency you're in. I can tell you the model. You pay for the data-bearing nodes. So essentially the members of the replica set are what you pay for, and you pay per node and you pay per year. And the price varies based on some other aspects of it, which I can tell you if you drop us a line. Vilokesh Verma, for our next session, do we have to install MongoDB for this? No, you will not have to install MongoDB for the session, but if you have it installed, you'll be able to copy some of the things I'm doing yourself, and that may help you. Pradnya Panamalkar, how we manage the database backup thing in NoSQL. We provide a complete set of backup tools both in the cloud using Cloud Manager and on-premise using Ops Manager to do complete backups with defined return time and return point objectives. Is there any level limit when embedding documents? There is, but I can't remember it offhand. One of the limits is at 16 megabytes, but whether you can nest documents infinitely, I haven't tried to do that and need to look that up. Jose, if you send me an email, Jose, if you send me an email, I will get back to you. My budding companion behind the scenes here, Sam, says the B2B, the Back to Basics email wasn't working for a period, but we fixed it now. Please resend your questions if you got a bounce or an issue there. Okay, Praveen Kumar, can a single node span across geographies, such as a primary and location one, secondary? Absolutely. You can have the primaries and secondaries located as long as they can see each other on the network. You can put them one end of the globe to the other, and lots of customers do that. Now, of course, your latency for writes is increased, so you need to be clever about how you set up your write concerns so you control that the latency for writes doesn't impact the overall performance of your system. Will this work for sharding also? Yes, exactly. Can you give a live example where it can be applied? We have customers using sharding and replica sets all over the world. Trying to think off the top of my head who would be a good example that's using sharding and geolocation. Probably Goldman Sachs is the company I think of who use it to distribute trade information. I am new to MongoDB. Can I use ORM? There are ORM systems. We don't recommend them. They hide what you're doing and they can generally impact your performance. What we find is you don't need an ORM system because, of course, the objects in your code can be stored directly in the database, so you don't need to map them. The purpose of an ORM is to take an object, which is what we use in our code, and turn it into a set of tables, which is what we store in a relational database. When you can store that object directly as a document, the need for an ORM kind of goes away. How do you handle geolocation reads to get consistent performance around the world? You can use what's called tag-aware sharding to locate the primaries for the relevant data close to where they're going to be used. So you can essentially tag European rights to a node in London and North American rights to a node in New York. And of course, you can have as many tags and as many shards as you need to get the level of granularity you want. Patrick Santos, do you mean in MongoDB there will be no joins? If not, how will it work like SQL? We have joins in MongoDB. We added it in 3.2, which was launched recently. There's called a dollar lookup, so you can do cross-collection joins. They are as efficient as joins in a real database, but it is possible to do them. Folks, I'm being told that we're probably going to have to wrap it up now. I've got through about, I don't know, 2/3 of the questions. Can I recommend, we will pull these questions out and respond to them directly if we can map them back to your emails. If you have questions that you want answered and you want to send it to Back to Basics, I'll respond directly to all of those questions. The other thing is we're going to be doing 5 more of these series. If you still have questions, please come along to the next talk and you can ask them again. The only questions I probably won't answer is stuff we've covered before. So think about this. You can ask us with the Back to Basics email. You can ask in the next chat room, and we will also take the remaining questions I haven't answered and try and get back to you directly in the chat room itself. So thanks very much, everybody, for an amazing hour of conversation. I think the questions have been really interesting. It's great to see that level of engagement. Do come and register for the next one. Do go to MongoDB World and use my code JOD to get a 25% discount. And if you go there, I will buy you a drink or a coffee or a soft drink, whatever you prefer. That's my open offer to you guys. So see you on the 24th. And thank you very much for attending today.